Hello, my name is David Voiles, and I'm a technical evangelist at Microsoft. And today, I'm going to discuss with you how to create hosted web applications with manifoldJS. Now, the first thing you need to understand is, what is a hosted web app? Well, a hosted web app are applications that are distributed through an app store, be it the iOS store, Android, use Google Play, or Microsoft's Windows 10 store. But the content itself remains on a web server. So you can use a combination of native code with JavaScript and other web code such as HTML5 and CSS to create a hybrid or hosted application. So now in all of these app stores, it'll be presented as a store app. It'll be discoverable just like any other store out there. It'll also have a tile or app icon so that this way users can launch your application on their home screen or start screen. It'll often have additional access to the various APIs in your device, be it your accelerometer, your camera, gyro, contacts, whatever it may be. But overall, the idea here is that your application lives on the web server and people are going to have the same experience across the board. So how do you build one? Well, first of all, you can use your editor of your choice, be it Visual Studio. Some people are still using Notepad++, Brackets, Vim, Atom, Sublime Text, wildly popular. You use whichever tool it is of your choice to write the web code. Then you're going to push your code to a repository, be it Git, SVN, Visual Studio Online. GitHub is my weapon of choice. I end up pushing all of my code there and open sourcing everything that I can. I also have a lot of content to be displaying today, which you can find on GitHub. And then you can deploy in your service. So you have this code, you're going to push it up to the repository, and now you're going to have a service reach into this repository to pull the code up so that people can view it. Amazon Web Services, Heroku, Parse, your private cloud if you want to have it on your own server, or you can use Microsoft Azure, which is what I'm going to be showcasing with you today. And finally, you can reach, it says Windows users here, but really you can reach anybody, iOS, Android, Windows, and even other devices. So what is manifoldJS? Well, first of all, it is a Node.js application that installs from Node Package Manager. You can run it on any platform and build for any platform. So that means I can run this on my Windows machine and I can still build an application that will work on an iOS device or Android device or Windows device. I can be on a Mac, which is what I end up using on my day-to-day work, and I can build for Windows, Android, or iOS, or I can work on Linux and deploy for different platforms as well. So you're not locked in by any means. It also helps you reach more users than ever by packaging a web experience as a native app across the three major platforms, Android, iOS, and Windows. It's also standards-based on the latest W3C manifest working draft, and I'll cover that in a little bit more detail later on. And best of all, it's open source, so anyone can contribute to it, and we have a number of people working on this at the moment. So why create a hosted web app, right? Well, what are the advantages here? Well, it's pretty clear. First of all, you can reach more users. So you can package your web experience as a native app across Android, iOS, and Windows. I've covered this before. You can also update without having to go through the app stores, right? So no more 6-day wait period or updating when you want to push, right? There's no need for approval. Now you're not circumventing anything, right? All of the app stores have agreed to using this W3C manifest. And I know you might be saying 6-day wait, like no one's doing that. What is 6 days? Well, this is actually what I picked up this week. The average app store review times, and I'm just showcasing what it is for the iOS app store as well as the Mac store. So that's 6 days if you're going for iOS, and 8 days is the average wait if you're going for the Mac store, app store. So it's quite a bit of time to wait for an application, right? So I know you're thinking like, I'm patient, I can wait 6 days. That's fine. But here's where an issue may arise. So you go to release your application, right? Looks good, but you realize later on, as you provide an update, that there's a bug somewhere down the road. So now all of a sudden users are downvoting you into oblivion. Oh, this app stinks, it doesn't work, continues to crash. And immediately you resolve this issue, you find out where the bug is, so it might just be one line of code you had to change. Perfect. That's great, but now you've pushed up this code, you've resubmitted to the App Store, but you've got to wait 6 days before the end user will ever get that code. The entire time you're being downvoted into oblivion and your app will never be seen in the store again. Not a very good experience, right? And we've seen this happen over and over again. Even some of the most wildly popular apps, you might go on and see and say, like, why does this app have 2-star rating across the board? And Apple even implemented a version of the review system where you can see, I want to see reviews just for this version of the application, for this exact reason. People's apps are getting downloaded into oblivion and never to be seen again. So here, you can make the change to your GitHub, or that's where I use in my example. I write code for my machine anywhere in the world, push to my GitHub repository. Azure's looking at that repository, so any changes I make immediately go to the site, and now users of my application can see those changes in seconds. I don't have to wait 6 days. I'm not getting downvoted into oblivion. I could say, hey, just launch the app again, or refresh the page, and you're there, right? What can be better than that? There's no need to reinvent the wheel as well, right? You already have a website, perfect. Why rewrite all that content for mobile apps, right? Why write it in native code for iOS? Why write it again for Android? Why write it a third time for Windows? It doesn't make sense. If you already have a great website, just reuse that content. It could save you a ton of money in the end run, and you don't have to have 3 different developers on retainer, right? Most developers don't have the tool set or skills to write 3 separate mobile applications, all of which in a different language. So now you have the opportunity to write it one time and have it work everywhere. And a concern I'll frequently hear is, oh, but the web is slow or JavaScript's slow. Take a look at some of my other talks or view my site at davevoyles.com, and you can see I have tons of content showcasing exactly how fast the web really can be. So how does manifoldJS work? Well, it takes the metadata about your site and generates a native hosted application. If the platform doesn't support a hosted app, we use Cordova to polyfill. So, like I mentioned before, on Windows platforms, we support JavaScript as a native language out of the box. So you can write an application in HTML5 and JavaScript, and it'll play just fine on our platform. You can make native calls to the operating system or different parts of the application, and it'll work perfectly fine. On iOS and Android, they don't quite support JavaScript and HTML. You're essentially going to be having a web view the entire time, so you're going to have to write JavaScript code that will talk to the bridge that allows you to connect to the native code. So if I want to access something like the camera on my device, in JavaScript, I would write something like cam.takephoto, and the code would realize I'm running on an iOS device, therefore I'm going to take this JavaScript and make the call to the Objective-C function that takes a photo. Or if I'm on an Android device, it's going to say I need to call the Java function of take a photo, the equivalent. So I'll go over that a little bit when I go a little bit detailed into Cordova. So metadata is stored as a JSON file, and I'll show you exactly what that looks like in a following slide. And this is called a web app manifest. So it's simply a JSON document that describes what your application should look like and where the mobile application can find different parts of it, such as the icons or properties you want to support, such as landscape or widescreen layouts. So the hybrid app is on your mobile device and then points back to a website with this manifest. It then takes that website and injects it into your application. So people will load up your app. That app will essentially have a window. It'll go out to your website, pull back that code, and inject it right there into the screen. So any changes you make to that website will immediately be propagated to those users as soon as they relaunch that application. So what is Cordova? Well, it is essentially a platform for building native mobile apps using HTML5, CSS, and JavaScript. So again, on Windows, we won't have to use this because our platform supports JavaScript and HTML5 out of the box. But for iOS and Android, this is what allows us to talk to those mobile devices while we only have to write JavaScript code, because Cordova has taken care of writing that native code, that Objective-C and that Java for us. So it's open source, so you can contribute to it as well. And you may also hear a PhoneGap as a popular term used. Now, essentially what PhoneGap does is it's an Adobe product that wraps Cordova and has some more additions to it. So I encourage you to take a look at that if you're a bit more curious about it. But whether you use Cordova or PhoneGap, you're not going to go wrong either way. For most intents and purposes, they're nearly identical for many people, but you're not going to go either way. But again, what this allows you to do is I can take that web code and I can run it on platforms that do not support HTML5 and JavaScript natively, such as iOS and Android. So the web app manifest. Let's take a look at what this document actually looks like. Well, again, here's a working draft from December of 2015. So this is about 2 weeks ago. So you can go there and you can get a better understanding of what this document looks like, how it came to be. But essentially it defines a JSON-based manifest to place metadata associated within an app. So again, that's things like the app name, links to the icons, the preferred URL to open. So maybe I don't want people to open the index or home page on my screen. Maybe I have a separate part of my mobile site or my website that I want mobile users to go to. Well, in that case, I can direct them very simply with this. I can have screen orientation, so I could say whether I want it in portrait or landscape, and I can define that in that JSON document. So as soon as users go to launch my application, it will always look the correct perspective. And also things like display mode. So I can say maybe I want it in full screen so I can hide all the web view buttons. Maybe I don't want them to have a back button or a forward button on it. And I want it to appear as though it's a native application. Well, I can do that as well. So installation, I went back. Installation, very simple process, right? Node Package Manager, install, and I'm going to install it globally on my machine. You don't have to. I just type manifoldJS. It's going to go to the server, to npm, pull down manifold, and run it on my machine. Takes a few seconds. Now building, we have really, I list 2 command line options here, but we have 2 command line options, and we have one option where we can do it straight through an actual website. So if I'm going to do command line, after I have manifold installed, I could say manifoldJS, and I'm going to pass in the URL of my website. So I could just leave it as manifoldJS, www.davevoyles.com, hit enter, and it's going to suddenly start generating the project for all the different platforms right there on my machine. So the options, see it's an optional array. I don't have to pass in any options at all. For more detailed information on options, you could look at the Manifold GitHub account or GitHub site. It's going to give you things like maybe I want a debug log or a more verbose debug log. I could check that out. That's also what the commands are there. So quite simply, what I honestly end up doing is I say manifold.js, pass in the name of my website, hit enter, and it'll generate a project for me locally. But also, there's the web generator. So maybe you don't want to install this on your machine. Maybe you're not very comfortable with the command line. That's fine. You can actually go to the manifold.js site, and I can provide a URL or a manifest. So I can either write one by hand on my own, or I can have this go to my website and try to find one for me. If it doesn't detect that you already have a JSON manifest, it'll actually generate one for you, and then you can then fill in the information on your own. So again, if you have a manifest that you've already defined, it's going to grab that. You're going to keep it in the same area where you keep your index.html or the root directory of your project. It's going to pick that up and have all information for you. If it's not there, it'll generate it for you. So right now I would do something like type in the name of my address, and you see on the right-hand side, I just have an empty object, right? I don't have any errors, any warnings, any suggestions for how to improve it. But after I enter my URL, I can hit the Get Started button, and this is what I would see. I did it for davevoyles.com, and on the right-hand side, it's showing me, as it's generating this project, it's going to say, I want the start URL to be davevoyles.com. I want the short name. Right now it says www.davevoyles.com. I would just say Dave Voyles. For icons, it's accepting an array of where these icons are stored. So in my particular case, in my images folder for my web application on the server, I might also have another folder in there. It says images, icons, and that's where I'd store the icons for iOS or Android. So this way people can launch using those icons. Again, display, I'd covered this before. It's whether I want full screen and I want to hide the buttons, or whether I do not want to hide buttons. Orientation, right now it's set to any, so users can use their mobile device and they can use it in a portrait view or landscape view. It's also giving me some warnings and saying things like, hey, you do not have a small square icon, so the Windows Store is going to request this. Or it's going to say you need another icon of this size because the iOS Store is going to need that. An Android Store is going to need a different icon. So You're going to need these icons one way or another, whether you're creating a completely native application or you're creating this hosted application using Manifold. So there's no way around that if you're going to get something into the store. So here we're just saying, hey, you're going to need an icon for this app so that users can launch it and find it inside the store. So demo, building a web app. So I'm going to show you exactly what this looks like inside of my browser. So I go to manifoldJS.com. And you see, like I mentioned before, I can use npm install and install manifold, or I can hit generate now. I'm going to type in the URL, so www.davevoyles.com. And because I don't have a manifest over there already, I'm just going to hit get started. And you see it's thinking. And like I mentioned before, it's giving me a list of warnings as well as some suggestions such as missing icons. And I can change this information. So right here, display, maybe orientation, I don't want any. Maybe I want to go to natural or landscape. I'll go portrait. And you see right over here on the right-hand side, it updated, so it now says orientation portrait. So I'm satisfied with the way my settings are now. So what I could do is say generate package. I hit that button. You see it's starting to think now. And as it's going to think, what's actually happening is on one of the servers that we provided in Azure, we are going to actually generate this package for you. So you don't have to install any of this. We're going to generate a zip file. And this zip file, you'll be able to download in about a minute. When it comes down, it'll have several projects in there. It'll have a Visual Studio solution. It'll also have an Android application, so this way I can open it up with Android App Studio. And it'll also have applications for iOS, so this way I can just open up Xcode if I was using this on a Mac, and I'd have that project right there. So I could open up the Xcode project, hit run, and I'm going to have my website as a mobile app right there. Does not get any easier than that. So it's going to take about a minute or two to package that up, but the huge selling point for this is that I can do this from any machine at any point. So even if I'm not home working on this, maybe at the office or I'm on my laptop, and I travel quite a bit for work, I have a great opportunity for me to create mobile applications from just about anywhere. So again, we're handling this in our virtual machines. All we're doing is generating a package for you based on the information you've given us, and in a moment I'll have a zip file with these applications that are ready to be published in the store. And here we go. It's downloading right now. So I'll open up this zip. You see, here are my projects. I have projects for, see if I can zoom in over here. Projects for Chrome, Cordova, Firefox, Web, Windows 10. So if I open up the Windows 10 project, I can see I have my manifest, source, and I have a next steps.readme, so I have instructions on what to do from here. But if I open up source, here I go, my Visual Studio project, and it's all in JavaScript. If I go back up, I can go to Cordova, and Cordova, I can go to platforms, and here we go, I have an Android project, so I can open up Android project right here. Here's my build.gradle on iOS. I also have same thing, my project, and I'm ready to go. Here we go, my Xcode project right inside of here. So if I was running this on my Mac, I could hit open or run. It's going to run that project, and I have a web application or a hosted web app ready to go. So again, we're creating the wrapper here with this project. I can then take this and drop it in the store, and I'm ready to go for iOS, Android, Windows, and you saw there are other applications there as well. So I have Chrome, I can make a Chrome extension or a Chrome app, Firefox app, web, which also works for Facebook. So you have quite a number of options right here. So there it is, building a web app. So now hosting the web app, right? You have your web code that you wrote, maybe HTML5, JavaScript, CSS, even PHP for those who enjoy pain. You need to have this hosted somewhere. So what I do is within Azure, I can spin up a new empty website. I can then click on the continuous deployment tab, and it's going to say, where is this code coming from? I need this website, but I need to know where you have it stored. So I can use something like Visual Studio Online, formerly TFS, Team Foundation Server. Maybe I have a local Git repository just on my machine and I don't even have it in the cloud. That's fine. I can pull information straight from my machine and then go right up to Azure where my web server is. But in my particular case, I frequently use GitHub. You can even use Dropbox or Bitbucket. So if you have your website saved in your Dropbox account, you can actually tie this Azure to your Dropbox, look at that folder where the website's stored, and pull it right up there. So any changes you make to that Dropbox website at any point will immediately be propagated to your website. So again, I frequently use GitHub, so I'll just give this access, or give Azure or that particular website access to my GitHub account. I can say, look through these repositories. I want you to use this particular repository. It'll pull up the information, and now I have a website that I can instantly make changes to. So again, here's how it looks. We have, I can do my development down here. It might be myself and some coworkers. We're going to push our code to something like CodePlex or GitHub. I can then have my Azure website look at my GitHub account, and at any point, as soon as I make change to GitHub code, it's going to send a hook or an event over to the Azure website and say, hey, someone made an update. You should grab this update. So grab that information, change the website, and now as soon as people navigate there on their mobile device, boom, they're good to go. So here's an example of something that just happened. Christmas and the holidays just passed. So our team, manifoldJS, largely led by Jeff Berthoff and our Microsoft evangelism team, he was working on the NORAD Santa tracker. So this app is platform agnostic. You can see we have Android, iOS, and Windows Phone, and you get the same experience across the board. And best of all, the app only had to be written one time. So now children can follow Santa Claus as he goes around the world. And it's much more convenient to write this once than have to write a native application 3 times on 3 different platforms, right? So there are also platform enhancements, right? Maybe you're writing for specifically Windows Phone. You could have something like Cortana integration. And you could ask her to open up the app to a specific section and say, hey, Cortana, in Dave's app, load up the section for students. And then I could dive directly into that application and my section towards students, right? Very quick, very easy to access some of this. Live tiles. So we have live tiles on our platform. So I could have updates about Santa's trip along the way. I could say, oh, he stopped in Philadelphia, which is where I live. So maybe my kid could know, hey, I could be next on his list as well. So you've created this web app, but you need to debug it somehow. Now, in the past, debugging a web application, not much fun, especially on mobile devices. So on desktop app, not so bad. We have some great tools. But on mobile devices, there really wasn't a great solution. So the TED team at Microsoft also started working on a tool for debugging mobile web apps called Vorlonjs. And again, this is an open source project that anyone can contribute to. And the idea behind it is that you'll have a web server that affords you a dashboard so you can view who's currently viewing your website, be it from a mobile device or from a desktop machine, and I can see the code and the experience that this user is going through. So it's all completely anonymous code. I simply know the device type that is connected to the website, and I'll show you how this works. So Vorlonjs is simply a plugin. So I go to my Vorlonjs dashboard. So my plugin is going to be HTML and CSS. So that's what's actually displayed. And the JavaScript or the data receivers done in JavaScript. And in between the website that the user is viewing and my dashboard, there's Node.js and Socket.io. That's the server I have this running on. They'll communicate and go back and forth. So I can see changes to the website as someone's viewing it. And also, I can make changes to the code to help them understand what's going on. So I can change the background perhaps from white to red on the fly, and a person can see this in real time. And it's a great example of how we can more easily work with some of our consumers to understand the issues they're going through. For example, someone might say, on my Android device, I'm getting this issue where the button is not laid out correctly. I could say, well, I don't have that specific device, right? There's a million SKUs of Android devices, so I can't really help. Or at least in the past, that's what we'd have to say. But now I could say, you know what? Go to the site right now. I'll ping your device as soon as I see you're on there, and I can see the HTML and CSS, and I can make adjustments to the layout right there. So I can more easily debug my application in real time, and we can communicate. So here's what the dashboard looks like. So you see on the left-hand side, I have my dashboard with the clients that are connected. So it's an array, starts at 0. I can see the DOM Explorer, and I can even have a JavaScript console for debugging. As we move to the middle of the page here, you can see I have a test page which is opened up with Chrome, also with Edge. So here's what the experience might look like for someone on a desktop machine. And on the right-hand side, I have a mobile device where I'm also testing this out. So I can see client 1 is likely a desktop machine, client 2 is likely a desktop machine, and client 3 is probably a Windows Phone device that's changing the user agent to make you think it's a desktop machine. So now I can see the viewers who are currently on my website. So before we get into that, I actually want to show you how this works. So what I did was, on my GitHub account, so github.com/DaveVoyles, I have a web app called Vorlonjs demo site. So what I did was I created a virtual machine that's running Node.js, and I just installed Vorlon on there. So instructions on how to install and how to run all this can be found on the Vorlon site. I'll have this in another video in the future. But you can see right here, I have a very, very straightforward and simple tutorial. You can even deploy this directly from Azure. So if you have an Azure account, you can hit one button and you'd have this up and running. So as the developer, I'm going to navigate to my dashboard, which is this right here. I can see I have 2 devices currently connected. These devices are a Windows desktop, that's what I'm currently using, and an iPhone that I currently have next to me. And for the end user, I'm going to have them go to this Vorlon website that I've created. So the Vorlon site actually is no more than, I'll show you real quick. Here we go. Okay, this is actually the code for the Vorlon site. So the Vorlon site is nothing more than an HTML5 boilerplate site that I went to. I just took HTML5 boilerplate, downloaded it, pushed it to GitHub, and I included the Vorlonjs script that I'll need to run. That's what allows my active website to communicate to my virtual machine so that I can have these two communicate. So that website, again, is just the HTML5 boilerplate. I've made no changes to this other than adding my JavaScript file that's running Vorlon. So to be very clear, the only people who can debug this site right now is myself, because I have the address of the dashboard, and that dashboard will generate a JavaScript debug file that I can then include on my website here. So it's not like I can take this and put it on any site like ESPN.com or Nickelodeon and debug their sites. I can only debug this on sites that I own, that I have access to, and can inject my JavaScript code to. So we can see I have a Windows machine, and I can even hit Identify Client. So now if I go over here, I see 0. So I know that I am user 0. And on iOS, I'm going to spin up my phone real quick. So here is what the application looks like on a mobile device. But let's see what happens. I can go to iOS, identify client. Oh, we have to refresh. Unless it's scrolled down a bit. So let's see, who gets connected now? So I'm going to refresh my page here. I think that's what happened, was my app actually fell asleep. So there's iOS. And now if I hit Identify Client, you see that 0 appear here. iOS is 0, and iOS is there. So what actually happened was I put my phone away for a while, fell asleep, so it disconnected from the site. And this was just pulling in old data. So once I refresh my client, it could show the devices that are actively connected. So very simple way of debugging what's going on. I can see all of the information that someone's currently viewing, right? So I can see the scripts that are attached. I can see JavaScript, the body, All right, all the shims that I have in place here. I can see XHR, so network requests. I can see information going back and forth. So very, very useful way for debugging some of these sites that I've created with Vorlonjs. So now, home stretch, wrapping up. Today I've showed you how you can reach more users by packaging your web experiences as native apps across Android, iOS, and Windows. I've also showed you that you can update without having to go through those app stores. So remember the approval process, I should say. So remember I showed you before, it could take up to 6 days to get an iOS app through the store. At least that's the current wait time as of right now. That's painful if you have one minor mistake in your application and you know what the simple fix is, right? You could spend all this time writing an app and it gets voted into oblivion, never to be seen again. Well, with manifoldJS, that's no longer an issue. No need to reinvent the wheel, right? Why rewrite the same application 3 times, especially if you have a website already? Now you're writing 4 applications. That's not very much fun. Don't rewrite all that code, reuse that code. And finally, I showed you how to do remote debugging with Vorlonjs. I'd implore you to go to the Vorlonjs site to learn more. We'll have more detailed tutorials. Also on my blog, I have several videos on how to actually get this up and running. I just wanted to show you a demo right there. And again, you can always go to my GitHub at github.com/DaveVoyles, and you can experiment it with yourself. So if there's anything else that I can do to help, feel free to reach out. Again, my name is Dave Voyles. You can find me on Twitter @DaveVoyles or my website, davevoyles.com. Thank you.